Hi guys, in this video we will be focusing on solving stoichiometric calculations based on balanced chemical equations, particularly problems that involves balancing chemical equations and then using their stoichiometric ratios in order to solve the mass needed. Okay, so let's start with number one. What mass of silver nitrate with the molar mass 169.9 grams per mole is needed to convert 2.33 grams of sodium carbonate with a molar mass of 106 grams per mole to silver carbonate? And B, what mass of Ag2CO3, so the silver carbonate, 275.7 grams per mole is formed? Okay. For number one, we're asked the mass of AgNO3. And for B, we're asked for the mass of Ag2CO3. So there are actually two questions from this one problem. Okay, so the first step in solving these type of problems is to identify which one or which ones are the reactant and the product. Okay, so the question actually gives us a clue. Okay, it says here AgNO3 is needed to convert 2.33 grams of Na₂CO3 to, so you can see here 2. So this should be our product, right? So this should be our product. So this is what we aim to make, Ag2CO3. And in order for this to be made, we want to mix AgNO3 and react to it with sodium carbonate. So this should be our reactant. Okay, so this is our reactant. Okay, so that is step one, identifying the reactant in the product. And step two is creating the balanced chemical equation. So now that we know the chemical reactant, AgNO3, right? AgNO3 and sodium carbonate producing Ag2CO3. But this is not a balanced equation. There is also a missing chemical here. Okay, so these types of equation is actually known as double displacement reaction. So this type of reaction are called double displacement reaction, which is common for ionic compounds. Okay, ionic compounds, when you see ionic compounds mixing, it's usually double displacement. So for an easier explanation, double displacement is particularly like this. So for instance, we have AB. So this is our cation A and an ion B reacted with CD. Okay. Through double displacement, they will replace each ion. Okay. So the product would be AB. As you can see here, A would be reacted to D plus Cb. Okay, because ion C will be reacted to the anion B. So this is basically the double displacement reaction. And with this in mind, we can identify the other product here. Okay, through double displacement reaction, we can assign this as A, B, and this will be C, D. Okay, so A, we have A here, and D, we have D here. Okay, we see here that A and D combine, so this should be C and B. Okay, C because we want cation first. Okay, the cation would be Na or sodium, which is this, and the anion will be nitrate for the NO3. So this should be the last product. But as you can see here, this is not a balanced chemical equation. As you can see here, there are two sodium here, and there is also only one sodium here. Okay, so with that, let's put 2 here This is important part as well. You must balance the chemical equation in order to have the correct stoichiometric ratios. Then there's also two silver here, and now there are also two nitrate here, right? 2 times NO3. So let's put 2 here. Okay. Now that is balance. Next step would be solving. Okay. So this step is the most easiest one. So let's start with A. Okay. A wants us to know the mass of AgNO3, starting from the given mass, which is 2.33 grams. So first, let's start with the given mass, which is 2.33 grams, and that is sodium carbonate. Okay. With that, we can convert this into mole of sodium carbonate by its molar mass, which is 106 grams. Okay, and cancel the grams, and we are left with mole of sodium carbonate. And this time, this would be the important part. Okay, we can use the balanced chemical equation in order for us to have a stoichiometric ratios, correct stoichiometric ratio. So 1 mole of sodium carbonate, and note, we want to find AgNO3. So let's relate sodium carbonate with AgNO3. So according to the balanced chemical equation, 1 mole of sodium carbonate is 2 mole AgNO3. So it needs to react with 2 mole AgNO3. Okay. And from this, we can relate them, and we can use the molar mass of silver nitrate, which is given 169.9 grams AgNO3. And with that, you can cancel the mole, and we are left with grams AgNO3, which is the unit that we want to find. And using your calculator, and that would be 7.47 grams AgNO3. Okay, so that is the answer for A. Okay, then let's answer now part B. Okay, for part B, we are asked with the product, so the mass of the product, but still starting with the given mass, 2.33 grams sodium carbonate. So it's the same process. Let's start with 2.33 grams of sodium carbonate and use its molar mass in order to relate with silver carbonate. Okay, so 1 mole of sodium carbonate. Okay, sodium carbonate is here. How many moles, according to the balanced chemical equation, is silver carbonate, which is this? It's 1 mole. Okay, this is a 1-to-1 ratio. And with that, we can relate them and use its molar mass. Okay, the molar mass of silver carbonate is 275.7 grams. And using your calculator, that would be 6.06 grams Ag2CO3. Okay, so that's how you answer this type of problems, okay? You have answered part A and part B. For practice, let's answer another question. Number 2, what mass of barium chloride with a molar mass 208.2 is required to completely react with 3.50 grams of sodium sulfate with a molar mass 142 grams per mole to form barium sulfate? What mass of barium sulfate is produced? Similar to number 1, it has two questions, okay? So first, we're asked the mass of barium chloride, and B, we're asked for the mass of barium sulfate. First step, let's determine which one are the reactant and the product. Okay, from the question, we want to form BaSO₄. So this is obvious. This should be the product. Then we are asked what mass of BaCl2 is required to completely react. Okay, react with sodium sulfate. So we want to react BaCl2 and Na₂SO₄. So we know that these are our reactant. Okay, we want them to with each other to form a product, and one of the product would be barium sulfate. Okay, so let's write BaCl2 plus sodium sulfate Na₂SO₄ forming BaSO. Okay, plus. Okay, we also have a missing product here. This is an ionic compounds. Thus, this is a double replacement or double displacement reaction. In order for us to determine this last product, we can do this method. We can assign them A, B, C, D. And you can see here barium, which is A, reacted with D. So this would be AD. So this should be our CB, which is Na and Cl. Na is the C, Cl is the B. Okay, and the next step is to check if it's a balanced chemical equation. And you can see here there are two sodium here in the reactant and two chloride in the reactant. So simply we can put 2 here and everything is balanced. Okay, barium is balanced, SO4 is balanced. So now we can answer our problems. Okay, we can use this chemical equation. Okay, let's start with problem 8. What mass of BaCl2 is needed? Starting with 3.50 grams sodium sulfate. Okay, 3.50 grams Na₂SO₄. Okay, let's use the molar mass of sodium sulfate, which is 142 grams, 1 mole of sodium sulfate. And in order for us to know the mass of BaCl2, let's relate them through this chemical equation. And 1 mole of Na₂SO₄ is just 1 mole, okay? 1 mole of BaCl2 according to this chemical equation. Then, from this, we can solve for the mass by relating it to its molar mass, which is 208.2 grams. And solve this through a calculator, and that would be 5.13 grams. Okay, next, let's start with B. So the same process, let's start with the 3.50 gram sodium sulfate. And using its molar mass, 1 mole sodium sulfate is 142 grams. Then 1 mole of, this time we're looking for barium sulfate. So that would be BaSO₄. Okay, 1 mole because according here, this is just 1, right? If we are looking for NaCl, that would be 2. Okay, but this time it's BaSO₄, and that would be 1 mole Na₂SO₄. So it's still 1-to-1 ratio, but they have different molar mass. So 1 mole BaSO₄, the molar mass is 233.4. Okay. Okay, I forgot to cancel here, but we're left in grams. of BaCl2 here. Okay, and here we can cancel mole BaSO4, mole sodium sulfate, and grams sodium sulfate, leaving us with gram BaSO4. So that would be 5.75 grams. Okay. Okay, for the last question, number 3. What mass of PbNO₃ is needed to react completely with 1.80 grams of KI to form PbI₂? What mass of PbI₂ is formed? So first, let's identify which ones are the reactant and product. Clue here, to form PbI₂. So obviously, this is our product. Next, mass of PbNO₃ needed to react completely with Ki. So we want to react Ki with PbNO₃. So this one are both reactant, okay, as well as Ki reactant. Okay. After that, the next step would be create a balanced chemical equation. Okay, we know now our reactant is PbNO₃ plus Ai, which forms PbI₂, and another product, which we will find. Okay, so as the same from problem number 1 and 2, this is a displacement reaction because these are reaction between two ionic compounds. So we can assign Pb as A, NO3 as B, and C, D. Okay, Pb here is our A, and I is our D. So this should be a CB. Okay, CB. So C is K, B is NO3. Okay, so let's see here, is everything balanced? We have one I here, but we have two I here, so we can put 2. Okay, but this time we have 2K here, and we have 1K here. Okay, and we also have 2 NO3 in the reactant and 1 NO3 in the product. So simply put 2 here as well. And now is a balanced chemical equation. And this time we can use this as a guide in solving our problems. Okay. So let's start with problem A. Okay, from the given 1.80 grams Ki, we want to know what mass of PbNO3 is needed. So we must relate Ki with PbNO3. So molar mass of Ki is 166 grams. Okay, and through this stoichiometric relationship or stoichiometric equation, we can relate Ki with PbNO3. Okay, we have 2 mole of Ki. 2 mole of Ki is needed to react with 1 mole of PbNO3. Okay, and from this, we can use the molar mass of PbNO3. 1 mole of PbNO3 is 331.22 grams. Okay, so we can cancel gram Ki, mole Ki, and mole PbNO3, leaving us with a gram unit PbNO3. And let's solve this, and that would be 1.795 grams or 1.80 grams. Okay, so that's the answer for problem A. And let's go with B. So the same process, but this time we are looking for the mass produced, or the mass PbI₂ produced or formed. So still starting with Ki. 1.80 grams Ki. And now let's relate Ki with PbI₂. Okay, so the same, 2 mole of Ki reacts with 1 mole PbI₂. Then 1 mole PbI₂ has a molar mass of 461. 461 grams. And that would be, okay, we can cancel down the moles and the gram Ki, leaving us with gram PbI₂, and that would be 2.499 grams, or simply 2.50 grams. Okay, so that's how you solve stoichiometric calculations based on balanced chemical equations. Okay, so thank you for watching. I hope you've learned from this video, and please check out my other videos and please subscribe to support the channel. Thank you.